For the longest time, the whole story of AI has been pretty simple. Build bigger and bigger models. But what if that's just the opening act? Today, we're diving into the next great evolution of AI. It's a huge shift away from these giant, all-knowing monoliths to something way more dynamic, way more resilient, and, well, truly intelligent. Let's get into it.
So this is the big question that frames our whole journey today. For years, the industry has been in this kind of arms race, right? Just assuming that bigger models are automatically better models. But we're starting to realize that the future of intelligence isn't about sheer size. It's about something much more interesting, like specialization and teamwork.
And this slide just nails the shift we're talking about. On the left, you've got the AI of today, this monolithic, brittle, centralized tower. And on the right, you see the future, a resilient, decentralized network that's built on all kinds of specialized skills. This transition right here is the core idea we're going to unpack.
Okay, so before we jump into the really cool solutions, we got to understand the problem, right? Why are we even moving away from these monoliths? What are the fundamental limits of trying to build one giant brain that can solve everything?
So right now, the AI world is pretty much run by what we call monolithic models. Just think of them as one single massive system that's been trained to be a jack of all trades. The dream has been to have one enormous brain that can do everything, from writing poetry to debugging code.
And this is where we hit the big fundamental problem. It's got this awesome name, the whack-a-mole effect. Imagine you're trying to improve one part of the model, okay? Let's say you're trying to make it safer. Well, in the process, you might accidentally break something else completely. All of a sudden, its math skills get worse, or its creative writing just falls apart. You fix one thing, two others pop.
And that whack-a-mole effect, that's not just a small bug, it's a huge deal. It's basically telling us that one single model probably can't ever be a true master of all trades. This whole generalist approach is hitting a wall, and that means it's time to start thinking completely differently about how we build intelligence itself.
All right, so if one giant brain isn't the answer, what is? Well, the first major shift is to stop thinking about intelligence as a solo act and start thinking of it as a team sport. It's about assembling an entire ecosystem of specialists.
And this new way of thinking has a name: compositional intelligence. Instead of one giant model, I want you to picture an entire ecosystem of what you could call micro-intelligences. Each one is a total expert in its own little domain, and they all work together. They collaborate to handle really complex tasks.
Now, here's how this actually works in practice, and it's kind of brilliant. A query comes in. Then a router model, think of it like a project manager, it looks at the task and sends it to the best specialist for that specific job. After that specialist does its thing, a judge model comes in and verifies the output to check for things like accuracy and safety. It's basically an assembly line of expertise.
And the benefits here are just massive. For starters, these specialists are way easier to evaluate. And when you update one, you don't break another, so no more whack-a-mole. Any errors get contained to just one module, instead of causing it total system meltdown. And on top of all that, it's way more cost-efficient, because you only have to fire up the specific expert you actually need for the task.
But don't think of this like a typical top-down company structure. The best way to picture it is like a mycelial network. You know, that incredible underground root system of fungi? It's this decentralized, super resilient web that can just reroute and adapt if one part gets damaged. Intelligence becomes this emergent property of the whole network.
Okay, so that's the software side of things, completely reimagined. But what about the hardware? What about the actual brains we're running this on? Well, this is where things get really wild. We're talking about building entirely new kinds of physical brains.
You see, for like 70 years, all our computers have been built on this one design, the von Neumann architecture, where the processor and memory are in two different places. This creates this huge traffic jam, a bottleneck called the memory wall. But neuromorphic chips, which are inspired by the human brain, they solve this problem by putting memory and processing right next to each other, which makes them incredibly efficient.
But it gets even crazier than that. We're moving beyond just using electricity. The computers of the future are actually going to perform calculations using the fundamental physics of the universe, things like the interference of light waves, the way DNA molecules bind together, and even the probability that you find in random noise.
This table here kind of lays out that future for us. You can see neuromorphic chips use these timed spikes of energy just like our neurons do, which makes them super low power. Then you've got photonic computers using light for unbelievably fast data transmission. And finally,
DNA computing, which uses molecular binding for just insane levels of parallelism and density. We're literally turning matter itself into mind. It's incredible.
Okay, let's take a breath. We've got a new software plan, a team of specialists. We've got mind-blowing new hardware that computes with physics itself. But there's one more piece to this puzzle, and honestly, it might be the most important one of all. It's about changing what AI is, moving it from a system that just matches patterns to one that actually understands the world. And that brings us to this huge idea, causal reasoning. It's the difference between knowing that two things happen together and actually understanding why they happen together. For example, an AI today knows that lightning is correlated with thunder, but it doesn't get the actual physics that causes the thunder. That's the huge gap we need to close if we want real, genuine intelligence. And the absolute pinnacle of this kind of thinking is something called counterfactual reasoning. It's that simple but profound ability to ask, what if? What if the conditions were different? What would have happened then? You see, this isn't just about predicting the future based on old data. It's about imagining alternate realities so you can understand the present. This is the bedrock of real intelligence, and it's what's missing today. So, how on earth do you teach an AI to think like that? Well, the answer isn't just feeding it more of the internet. It needs a body. This slide perfectly contrasts today's internet AI, which just learns passively from a static library of human stuff, with embodied AI, which learns actively by interacting with the messy, unpredictable real world.
Just think about how a kid learns, right? An embodied AI does the same thing. It sees the world through sensors, it acts within that world, and, this is the most important part, it learns from the consequences of its actions. It pokes things, it fails, it tries again. Just like a toddler, it builds a model of physics and logic, not because someone told it the rules, but by doing. And this is how we get from a fancy text predictor to a true reasoning engine.
Okay, so let's pull all these amazing threads together. We've got orchestrated intelligence, we have physical computing, and we have causal reasoning. What does the future actually look like when you combine all of these world-changing breakthroughs?
So when you boil it all down, these are the massive paradigm shifts we're talking about. We're going from a single monolithic model to an orchestrated ecosystem of specialists. We're shifting from purely digital computing to physical computing. We're leaping from simple correlation to deep causation. And all of this enables one last crucial shift, moving from AI as a closed-off product owned by one company to an open protocol that anyone can build on.
There's this quote from the source material that I just absolutely love. It says, "We're kind of like early astronomers who could see the stars but had no idea what they were actually made of. These new architectures are like the invention of spectroscopy, a brand new tool that finally lets us understand the true composition of intelligence. It's a fundamentally new way of seeing the world."
And so we end with this one question. For decades, we've been trying to build intelligence, like a machine in a factory. But this new paradigm, it suggests something else entirely. It suggests a future where intelligence isn't built, but is cultivated, nurtured, and grown, like a forest or that mycelial network. And that, well, that changes everything.